All right, good morning. Hi, yes. You guys know I love a good hi. Hey Leo, hey Shada. What's up, friends? Matthew. Selena, what's up? Okay. All right. That's good. I got 4 highs to start the day. I love it. Feeling strong. All right. So I hope you guys had a good weekend. Been a while since we actually taught some stuff. So I've gotten most people's performance tasks. Aiden, hey, did the Easter Bunny visit you? Of course. Why wouldn't he? Got a lot of good, Easter presents. But so I got most people's performance tasks. There's still a small handful that I don't have. So nobody's is graded yet. So I know that they should be all graded and entered in by tomorrow. That's my goal to hit, and I think should happen, feasibly so. Okay, so look for that. But if there's still a couple stragglers, so if you or someone, or if you know somebody, okay, reach out to people, say, hey, did you turn in your performance task, so I can get that all good to go. All right. Hope everyone had a great weekend. Easter, if you celebrate Easter, great. And we're starting our next unit, right, which is starting off with some really good stuff. Also some great info here. So I don't know if you guys checked the stream title, but some great new commands that you can throw into the chat, !art or !C4. That's going to hit you with some really good information if you type that into the chat right now. One of those, or both, but individually. Right, so certain people in classes have challenged me to Connect 4. Obviously, I'm dominating. Like, there was never any doubt that, people just can't take me down at Connect 4. I'm sitting at a good 3-1 right now. All right, respectable. Had one lapse in judgment where I got the loss, but other than that, doing great. All right, thank you, Matthew. The other thing is you can check out a great YouTube video of me guest starring on Miss Jury's YouTube channel as we talk about the artist / mathematician MC Escher. So be sure to hop over to that. Drop a big like, comment, subscribe, and that's just entertainment. Since I am such a popular Twitch streamer, Miss Jury hired me to come onto her videos so that I could try to boost the views, since I'm a modern day influencer. So, what can I say? I'm just trying to spread the love here, to not only my own content, but other teachers as well. Got some really good stuff there. Okay. Well, let's go ahead and start off today's lesson then. So we're going to start our next unit, which is conic sections and systems of equations. Okay, so this will be a lot of new stuff. well, not today at least, but overall, this unit as a whole, there's more new stuff than you're probably used to. Like, for example, exponentials and logarithms. You guys saw exponentials and logarithms in Algebra 2. We did learn a couple new properties, and we learned some new different word problems that we can use them in. So like rationals, polynomials. You guys knew rationals and polynomials. We added some, a couple new things here and there. That's kind of the way it's been most of the year. So now we're getting into a lot of brand new stuff. Okay, now there's still some mixed with some old stuff, or some just using old stuff and adding to it. But we will go through and get to like especially with these first few lessons with conic sections, it'll be a handful of things that we've never seen. Okay, but today, still starting with stuff that we are familiar with, which is circles. All right, so everybody bust out your geometry notes from last year. When did you take geometry? Your college algebra now. Last semester, algebra 2. Before that, geometry. Probably, I think last fall. Took geometry. So I know you still have all your geometry notes and geometry, everything, just all that. Just go ahead and get it out. Great. I know you remember everything perfectly. Okay, so for this warm-up, find the center and radius of each circle. All right, so this is something that you did talk about in geometry, and hopefully it's a little familiar at least, that the center of this circle would be -7, +12. Okay, and we get that from the +7 and the -12. So you might notice the signs are switched. All right, be super careful about that. X +7 means the x value is actually -7 at the center. Y -12 actually means the y value is +12 at the center. And as for the radius, we instead look at this number over here, and we're going to take the square root of it. So the radius is 9. Same thing down here. I'm looking at these, so that tells me the center is 1 and -4. The signs switch from what we see in the equation. Right, -1, so we put +1, +4, so we put -4. And the radius, so we look at the right side, 7. Now the radius is not 7. Okay, remember, just like on the first one, we take the square root, not 8. Why did I write 8? We take the square root of whatever it is. Now, square root of 7, 7's not a perfect square. So obviously I do not want a decimal. So we would just leave this as square root of 7. But again, you perfectly remember that from geometry. So I don't even know why I'm talking about it now, because that was just easy for you. Super easy. Okay. Oh, I lost my... Okay. All right. So, conic sections. That name, conic sections, comes from looking at... Conic comes from cone. So if we look at this like double cone, these two cones that are touching, meeting at those points, and we're going to talk about what happens when we cut through them at different spots. Right. So our first example is if we were just to cut straight across. Right. So for example, up there where this shows, or we could cut straight across here, or straight across here, or straight across here, or straight across here, whatever. The point is, if I cut straight across anywhere here, and then I look at the cross section, which means I take those pieces apart that I cut and I look at the shape that's made on the inside, what shape would it be? Well, it'd be a circle. Right, and we can see that in the picture that was already on the screen, that circle that's made from that cut. right, after we look at the cross sections, which cross section, another geometry term that you know and love. So depending on the cut we'll make, it'll make different shapes, but this one today we're talking about circle. All right, circle. The formal definition is a set of points that are all equidistant from a center. All right, so a set of points that are all equidistant from a center. And so that just means any point that I choose, if I look at the distance of that point to the center of the circle, they're all the same distance away. And what is that distance? We call that distance r, which I'm sure you know. Stands for the radius. Okay. We also have the diameter. Which is just double the length of the radius. Okay, diameter is all the way across the circle. Radius is just to the center. And a few other circle things that we won't use a lot, but good to remember, refresh. Area of a circle, pi r squared. Circumference of a circle, 2 pi r. So circumference, remember, is like the perimeter. What's the distance around the edge of the circle? If I took that circle and I cut it and laid it out flat, what's the length of that? 2 pi times r. All right, so first off, the equation of a circle that's in standard form. All right, this is what the warm-up information is, how we determine that. Right, but this is the standard form, the x minus h squared plus y minus k squared equals r squared. Okay. And the radius, so it's just r. Now notice that on the right side is r squared. So that's why, like in the warm-up, we had to take the square root of that to figure out what just the radius is. It's not bow tie Tuesday. All right, Abby, but that's true. But just because it's not bow tie Tuesday doesn't mean I'm not allowed to wear bow ties on other days. It just means that on Tuesdays I should be wearing a bow tie. Correct? This is my interpretation of it. So when I wear a bow tie tomorrow as well for bow tie Tuesday, but I can still wear a bow tie if I want another day, right? Right? Don't come for me here, Abby. Right? Here, this will help. Hold up. Okay. Now you're mesmerized so that you can just calm down. Okay, right? Radius is r. Center is hk. Right, so we look at those values here and here. But again, that's a review. You knew that already. So the general form of a circle. All right, so we have standard form. Now we have what's called general form. All right, which looks like this, where everything is all together on one side and it's all multiplied out. All right. The thing that kind of isn't great about general form is we don't know a lot of information immediately. Right? When I look at standard form, I can immediately figure out what's the radius, what's the center. If I look at the general form, we can't do that. Right? There's no good like formula that like, oh, the center would be these numbers or the radius would be these numbers. So what we're going to do is we're going to practice then starting in general form and then going to standard form. Right, so here's how we're going to do that. We're going to move constants to the other side, right? So just the numbers. We're going to group terms of the same variable together, so like x and x squared, y and y squared. We're going to complete the square. Now, do we remember what completing the square is? Now, we talked about that at the very beginning of the semester. Okay, completing the square. Right, where we add b over 2 squared. However, don't forget we need to do stuff to both sides of an equation. If we add something on one side, we have to add it on the other side too. Right. And as is bolded and underlined here, we're going to complete the square twice. We're going to do it once for the x variables and once for the y variables. So here's kind of our general steps that we're going to follow. So change to standard form. X squared plus y squared minus 10x plus 8y plus 8 equals 0. All right. So we're going to get good at this because we're going to do this in several of the next sections. So we'll probably do a question like this or similar to this like every day for the next week or two. First up, take the constant, move it to the other side. So I just subtracted 8 from both sides. After that, group x variables together, group y variables together. All right, so I'm just going to rearrange the left. X squared minus 10x plus y squared plus 8y. And then I'm going to leave myself some space right after the groupings because I need to do the completing the square. Okay, so I'm going to do it once for the x's, once for the y's. So for the x's, so b over 2 squared. Here's b. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So I'm going to add 25 there. But like I mentioned, we have to do it to both sides of the equation. So I'm also going to add 25 on the right side. Now I look at the y variables. Here's that b. Okay, 8 over 2 is 4. 4 squared is 16. So I will add 16 in here. And I'll do it to both sides of the equation to keep things balanced. So on the right, we can just do the calculations, right? So negative 8 plus 25, that would be 17. No, wait, what? Yes, 17. Negative 8 plus 25, 17. 17 plus 16, 33. And for each of these, I'm going to factor. So I'm going to first factor these three terms. So I'm trying to think of two numbers that multiply to make 25, but add together to make negative 10. So that's negative 5 and negative 5, right? Negative 5 times negative 5, 25. Negative 5 plus negative 5, negative 10. So x minus 5 times x minus 5. Well, I can just write that as x minus 5 squared. And now I'm going to factor these three terms. Two numbers that multiply to make 16, but add together to make 8. That would be positive 4 and positive 4. So I could write that as y plus 4 squared. And there's my answer. Yeah, this answer is more descriptive. It's more useful in that we can immediately know information. Right? If the question asked me, I could immediately look at this and say, hey, the center is 5, negative 4. And the radius is the square root of 33. So the standard form, much more helpful in figuring out information about the circle. Is like this more kind of slow, methodical changing of the lights, or like the faster kind of strobe light? Which one will bring in more viewers? Strobe. It's a little more intense, a little more flashy, you know. The slower ones, a little more peaceful and calming. So you're right. We really want to leap out at the viewers. Hit them with the strobe. All right, throw on some techno music in your house right now, and you got a dance party. I will provide the lighting. All right, find the center and radius of each circle. Well, to find the center and radius, I would love it if it's in standard form, but it's not. It's in general form, so let's change it. First step, take your constant term, move it over to the left, or sorry, to the right side. And on the left side, we're going to group X stuff together, group Y stuff together. All right, so I kind of did two steps in one. Move the constant over and also grouped those terms together. So now it's time to complete the square. So first for the x's, b over 2, so that's 25. And then 25 squared, oh geez. Plus 625, plus 625. And then for the 12, so 12 over 2 is 6. 6 squared, 36. So add 36. But don't forget both sides. I think you can just barely see that 36. All right, but yeah, 36. Okay, so on the right, adding those things together, so that would be negative 30 plus 36 is just 6. So 6 plus 625, 631. And on the left side, let's factor. So the whole reason of completing the square is we can factor into a perfect square. So I know I should have x plus or minus something squared. Okay, so two numbers that make 625 when I multiply, but add together to make negative 50. That would be negative 25 and negative 25. So x minus 25 squared plus plus 12y plus 36. So y plus 6 squared. All right, so this is the standard form, which is great, but it's not what the question asked for. At least explicitly, it says, what's the radius? What's the center? Well, we can figure that out now that it's in standard form. So my center, 25, negative 6. The radius, right? Don't get fooled. People always try to put like, oh, the radius is 631. No. The radius is the square root of 631, which is not a perfect square, right? No, there's no way. Boom. Questions? All right, it's not too bad as long as you can remember how to complete the square. And even then. Okay. Let's go to our next type of problem then. Finding the x and y intercepts of the circle. Okay, so putting in general form to standard form probably didn't do in geometry. And this as well probably didn't do in geometry. Maybe. Because this one's not wild. All right, but we may not remember immediately what it is we need to do. So let's first, why is this? Start with the x-intercepts, because why not? If I could write this the way I want to. X-intercepts. We've talked about before, the way that we find x-intercepts, or the way that we find y-intercepts, for any equation, no matter what it is, okay, we just need to plug something in. All right, so specifically, for x-intercepts, all we need to do is plug in y equals 0. All right, so let's put a 0 there and then solve for x. So x plus 6 squared plus 0 minus 5 is negative 5. Negative 5 squared is 25. And then equals 45. So now we solve. Subtract 25 from both sides. 45 minus 25 is 20. How do we get rid of squared? Take a square root. So square root of 20. Now, since we have square root, then we need plus or minus. Right? Always forget, or don't always forget. Always remember. There we go. Always remember the plus or minus. And subtract 6. Now there is one small thing more, is that looking at the negative 6 plus or minus root 20, square root of 20 is the same thing as square root of 4 times square root of 5. And the square root of 4 is just 2. So I can simplify radicals. If you can simplify it, always do that. So negative 6 plus or minus 2 root 5. But still not done. All right, remember how picky I am. All right, especially in a problem that's asking for x-intercepts. So we don't just want to say, oh, x is -6 plus or minus 2 root 5. Right? Intercepts are points. They're coordinates. They're ordered pairs. So to be completely correct, I would want to put them inside of an ordered pair. All right, now you could write two separate ones, -6 plus 2 root 5, 0, and then -6 minus 2 root 5, 0. Or we can write them together like this with the plus or minus. So this represents two different points. One of the points if you add the 2 root 5, one of the points if you subtract the 2 root 5. Either way is fine. All right, so let's do the y-intercepts now. So similar. How do we find y-intercepts? Well, we did this with polynomials. We did this with rationals. To find a y-intercept, you just plug in x equals 0. All right, so I'll plug in 0 here. So 0 plus 6 is 6. 6 squared is 36. Plus y minus 5 squared equals 45. Subtract 36 from both sides. 45 minus 36 is 9. Square root both sides. So square root of 9 is 3, but plus minus, don't forget it. Add 5 to both sides. So two possible values, and there's not any weird square roots or anything in this one, so I want to actually do the calculation. Right? Because I went to college. I don't know if you guys knew, and I can figure out 5 plus 3 is 8. 5 minus 3 is 2. So I have two y-intercepts. 0, 2. And 0, 8. Now, does it make sense that we have two x-intercepts and two y-intercepts? That seems kind of weird, but that should make sense if we remember what the heck we're actually talking about. All right, so remember, this is a circle, right? So if I think about the graph of the circle, okay, this particular circle, so this doesn't match this particular x-intercepts, but if I have something like this, right, it makes sense that I could have two x-intercepts and two y-intercepts. So that's something we're kind of not used to. At least for y-intercepts, we're used to just having one y-intercept. Right, because we've mostly been dealing with functions. But now that we're dealing with conic sections, these are not functions. Right, we can clearly see how these fail the vertical line test, like everywhere pretty much. Okay, so they're not functions, and we've been dealing with a lot of functions, but these conics will not be. They will not pass the vertical line test. But that's okay. Right, it still is a thing that we'll learn about. Just means it's not a function. Right. What do we got? 1206. Great. Let's do our last one here. Same thing, x and y intercepts. So let's start with x-intercepts, which means we're going to plug in 0 for y. X plus 2 squared. 0 minus 3 is negative 3. Negative 3 squared is 9. Equals 13. Subtract 9 from both sides. Quantity of x plus 2 squared equals 4. Square root both sides. Square root of 4 is 2, but don't forget plus minus. And then subtract 2. So I have negative 2 plus or minus 2. So that'll give me 2 distinct answers. Negative 2 plus 2 is 0. Negative 2 minus 2 is negative 4. And then don't forget to actually write your answers as coordinates. So 0, 0. And, oops, it's an x-intercept, so negative 4, 0. So my x-intercepts. Now let's do the y's. So that means we're going to plug in 0 for x. 0 plus 2 is 2. 2 squared is 4. Oops, not equals. Subtract 4 from both sides. Y minus 3 squared is 9. Square root. Square root of 9 is 3. So plus or minus 3 since it was a square root. Add 3 to both sides. Three plus or minus 3, so we get 2 answers. 3 plus 3 is 6. 3 minus 3 is 0. All right, so technically, if 0, 0 is one of the intercepts, then it'll be for both, right? Because if both the x value and the y value are 0, it's crossing the x-axis and the y-axis at the same time for that point. But whatever. We still needed to find the 0, 6 at least anyways, so we still have to go through and solve to see what we get. So I could sketch this out. 0, 0, negative 4, 0, 0, 6. Right. Actually, that would look pretty rough. Yeah, maybe I should actually just show the graph because I would draw it really badly. Let me pull up Desmos really quick. I don't want to draw an ellipse. Let's see, what was our original equation? X plus 2 squared plus y minus 3 squared equals 13. And I'll pull this up. There you go. Here's that graph. We can see our intercepts, negative 4, 0, 0, 0, 0, 6. Exactly what we found. Okay. So that's all I've got for today. I didn't have an assignment or anything to send out.